I want to show you how to solve logarithmic equations and other equations involving logs. But now we're going to have a shift over to algebra. Before we were using primarily numbers, so I'd like you to have a go at simplifying the following expressions that are going to appear on the board. Now, we have 4 expressions here, and we're almost doing the reverse of what we did in the previous video, that we are simplifying these and breaking them down into multiple logs instead of taking logs and combining them. What I'd like you to do is to break down these expressions so that your answers only have log ax, log ay, and log az. You're allowed to have coefficients, but your answers must have just numbers or log ax, log ay, or log az. You don't have to have all of them. So for example here we've got log ax squared yz cubed. You have to write that in terms of log ax, log ay, and log az. No squares, no cubes, things like that. So pause the video, have a go, and then we'll go through it. So the first thing to note is that the first example here is a product. It's a 3-way product. You can extend the addition and the subtraction laws when you have 3 things multiplied together. Works the same. This is log ax squared yz cubed, so it's a product, so I can split it up to log ax squared log ay plus log a z cubed. But we're not allowed to have log ax squared. I said the answer has to be in terms of log ax, log ay, and log az. Log ax squared is not the same as log ax. X and x squared are not the same thing. So if I'm only allowed to have log ax, how am I going to get rid of that 2? You use the third log law to bring the coefficient back down. Before we were putting the coefficient in front of the log up as a power, now we're doing the reverse. You need to be happy to use the log laws both ways. So this becomes 2 log ax, log ay, that's allowed in the answer, and the 3 also has to come down. So that's the answer. 2 log ax plus log ay plus 3 log az. Right, on to the next one. We are now doing the log of a quotient, a division. So let's use the second log law. Log ax minus log ay cubed. Log ax is fine. Log ay cubed, I'm not happy about that 3, so what do? I pop the 3 down. And that's the answer. Right, this one here you have to be a little bit careful. It's a quotient. But the whole of the x root y is going to have to be dealt with carefully. So I've got something divided by something, so just use brackets. You could do log a of this. Don't worry too much about that just yet. X root y minus log a z. Now log az is fine, I'm allowed to have log az. Now what am I going to have to do with this? It started off being a quotient, but this term here is a product. And what do we do with the product? We split it up using addition. So that's log ax, that's good, I'm allowed to have log ax, plus log a root y minus log az. Now, if you stop there, that's not actually finished, because log ax and log az, they're allowed. Log a root y is not the same as log ay. So how do I get rid of that square root? So, a square root can be written as the power of a half. So that's the next thing to do. We do log ax plus log ay to the half. Why did I write it as a power of a half? Because the log law can deal with powers. That power can be brought down. So the final answer is log ax plus a half log ay minus log az. The final one, log a x over a to the 4, it's a division, so we can write log ax minus log a to the 4. Now, log ax was allowed in the answer, but log a to the 4 wasn't. You can go further than this. Log ax, remember we had that in a previous video. this, you don't leave this as log a to the 4, because that should be an obvious result. What does this really say? What power of a gives me a to the 4? It's 4. If you're inside of the logs in terms of a, and that's a, there's probably a simplification that can occur. I can't do anything with the log ax because I don't know what a and x are. They're variables. I don't know what values they take. But here, log a, whatever a is, the power of a to the 4 will give me a to the 4. So that's actually just minus 4. So you need to be careful about that. Okay, let's get cracking with a logarithmic equation. Now, I want a word of warning first. When you're solving a logarithmic equation, don't start thinking, oh, that means 2 to the power of something is x plus 15, and that means 2 to the power of something is x, and trying to really rationalise what's going on there. It's good to have those thoughts, but only entertain those thoughts when you have a single logarithm. When you're presented with an equation like this, don't worry too much until you have combined the logs together, so you have a single logarithm in this equation. How do we do that? Well, hopefully by now you realise we use the logarithmic laws, the log laws. What's going on here? We've got the subtraction of two logs. But, what do we say? Check if there are coefficients. No? Yes. I've got to bring that up. So the first thing you should do is you say log 2x plus 15. Be careful. The 2 pops up as a power in whatever is inside the log. So you've got to take the whole of x plus 15 and square it. Minus log 2x is equal to 6. Now we are subtracting 2 logs. We can combine them. Now you can multiply this x plus 15 all squared out now, or you can wait. I'm just going to wait a step. It doesn't really matter. Now we can combine the 2 logs, because when you can combine 2 logs is when the coefficients are 1 and you've got additional subtraction. It's subtraction here, so we will divide. So we'll do log 2 x plus 15 all squared over x is equal to 6. Now is the time to use the definition of the log and to activate your thinking as to what this really represents. What did we say this statement means? A single log means that base to that power is equivalent to this. So now the goal for logarithmic equations is ultimately to remove the logs altogether. To that power is equivalent to this. So now the goal for logarithmic equations is ultimately to remove the logs altogether. So 2 to the power of 6 is x plus 15 squared divided by x. Now we know 2 to the power of 6 is 64. And now let's bring the 64 across. 64x. Now let's multiply that out. And the rest of this exercise is solving this quadratic. So bring the 64 across and you end up with x squared minus 34x plus 225 is equal to 0. Now, we solve the quadratic. Solve the quadratic. And the two solutions are 25 and 9. You can factorise that as x minus 25, x minus 9. And the two solutions are 25 and 9. Now, when you solve this quadratic, that quadratic doesn't have any memory. It has no idea that that quadratic is actually solving this equation. So this is an example where you actually don't just blindly solve the quadratic. Check that the results make sense. How? Check if I put these back in, that they make sense. What do you need to be worried about? Remember we did that problem where you tried to log a negative and you had a maths error. If your solutions when put back in will produce a negative result when inside the log, you have an issue. Here, we don't have a problem. If I put 25 into there and there, you're logging a positive number, no problem. If I put 9 in, no problem. So actually both solutions are valid, and there are two solutions to this equation. However, let's say one of the results was negative. If x was, say, -4. Let's say the quadratic produced a value of -4. If I put -4 into there, okay, no problem. But it has to work for both. I cannot put -4 in there, because I'll end up doing log of -4, which is a problem. Now, sometimes negative results can be okay. Don't just say to yourself, okay, I'll get a negative number, yeah, I'm going to log a negative number, and it's going to be a problem. That's not always accurate. Why? Because let's say in my equation that I had x plus 10 as one term, and x plus 4 as another term. If you get an answer -3, if you put it into there, it becomes 7. -3 plus 10. If you put it into there, it becomes 1. So actually, a negative result is not the problem. The problem is the inside of the log being negative. All I'm saying you should do is when you get your solutions, check that the inside of both logs are positive. If any of them are negative, that's a problem, and that solution, whatever the value is, must be rejected. It could be a positive number's a problem. Right, these brackets could be x minus 4, so a positive number becomes negative when you put it inside the log. So just check your solutions make sense, and in this example, two solutions, 25 and 9, would solve the problem.